Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the last lecture of second week of this ongoing online course on engineering or architectural graphics part 2, where we are discussing about isometric projection. In the past few lectures, we have seen how to draw isometric projection of different two-dimensional shapes, three-dimensional solids, derived solids, regular solids. Now, one solid which we haven't talked about as yet is sphere. So, if we have to draw isometric projection of the sphere, and as we have seen, we always derive the isometric projection from the orthographic projection. So, we would very clearly know that when we see a sphere in isometric projection, similar to orthographic projection, it will be seen as a circle. But what is the dimension of that? How do we derive the dimension of it? Let us see it in this lecture, and I will take certain other examples to make it very clear to you how do we draw spheres and hemispheres, and also when they are together with other solids, they are attached to it, kept on them, or there is a combination of solid. So, let us start with a very simple sphere first and understand the basics of it. Now, we have a sphere here. To start drawing it, we have to assume different circular planes at which it is cutting. So, if this is the circle this is the sphere which we are talking about, and this is the center of the sphere, and the radius is r. Now, also to remind you what we have been doing, how we have been drawing is, we were taking the actual dimensions. We were not using the isometric scale because it was much easier for us. Now, the sphere cannot be drawn just with the actual dimensions, and I will show you how it does not happen that way. So, assume that this sphere is getting cut by a plane, a vertical plane which is cutting it in two halves. There is a horizontal plane passing through this which is again cutting it in two halves, and there is another vertical plane which is seen like a vertical parallel to VP, which is again cutting it. So, for example, this is the plane which we are assuming. So, this sphere is getting cut through three planes, perpendicular planes. Okay. Now, I will try, and since it is passing through the center, all the three planes are passing through the center, what we are going to see where the plane is cutting is the circle with the diameter same as that of the sphere. So, I will start drawing these three circles, and then we will see what a sphere looks like. Okay. So, let us assume that we first drawing the horizontal plane. So, let me draw the first circle which is the horizontal one. So, just as we used to draw the circles, we will draw this. Now, I am drawing it in green, which is what I use for the construction line, is because this is not the final one, but this is the circle which is where the first plane, the horizontal plane, cuts the sphere, and this is the center. Now, there is another plane which is cutting the same sphere, passing through the same center of the sphere, but vertical, perpendicular to HP and parallel to VP. Okay. So, this square is going to be here. So, if you draw it, this is where your second square is going to come, which will contain the circle which we will now see. So, this is a horizontal circle which is generated when we cut the sphere into two halves by a plane which is parallel to HP and perpendicular to VP. Now, another one. So, what we have here is, this is the other circle. Now, this is perpendicular to the HP, but parallel to the VP. So, this is the second circle. Okay. Now, so this is the second circle. Now, we are drawing the third one, which is again going to pass through. So, if you look at this, the center remains the same, the intersection points, they will remain the same, the center is the same, and then we will draw it again. So, this is how the sphere is actually, it has these three circles. So, if we rotate any one of these circles which we are getting, we will effectively get the sphere. Now, if you look at this, this is the point, if this was the point P, which is resting on the ground on another solid here, but this is the point P here, right, and this is C, which is the center of the sphere. If you look at this distance CP is actually the isometric radius. So, if we are using the isometric dimensions, then this is the isometric radius. Okay. Now, if I draw a circle, now we very clearly know that from wherever we see the sphere, a complete sphere, we will be seeing it like a circle. But now, if I have to rotate any one of the circle 360 degree, what we will get? We will actually get a circle, which is how it will be seen in isometric, but what radius? So, if we take this radius, which is this distance, so say d, small d. If I take this center, the center remains the same. If I take this distance, then this is again the same, this is the same, this is the same distance, this is the same distance, this is again the same distance, and we come back here. So, we actually get a circle if we choose the same center, but the radius being this. So, now I will change the color again, and now if I draw this, since I am drawing freehand, I may not be getting a perfect circle, but if you draw it with the help of stationery, you will actually get the exact circle which we will be seeing as sphere. Now, what is happening here? We have to understand what is the radius. So, we have the center, we have identified the center, and here if you see, this is the revised radius. So, originally the radius CP is exactly this distance CP. Okay. So, if we are using isometric scale, then in that this CP will be the isometric radius. So, suppose for example, if we have this as 1 centimeter originally, the actual dimension of the sphere, this isometric radius will be 0.815 centimeters. This is what we will take as isometric radius, and how much will be the d? D will be equal to 1 centimeter, which is the actual one. This is how we will draw the sphere, very simple. So, if we can locate the radius of it, we can actually draw the sphere. However, what we have been seeing is that we did not take the isometric dimensions, we have been taking the actual dimensions and drawing the isometric view. So, our views would actually look bigger than the actuals. Now, what happens if we were using the actual dimensions? In that case, this d, if we are not taking the iso radius, we are taking the actual radius here, which is the actual radius, then this d will be the actual radius, which is say r, which is here. So, it will be r into 1.2 approximately. It will be 1.2 times the actual radius if we are using the way we have been drawing. If we are using the iso radius, then all we have to do is use the exact same radius, which was actually the r here. Without thinking anything, if you can locate the center, you can very conveniently draw the sphere. So, actually the point where the sphere rests is this point P, but what will be seen in the isometric view is slightly different, because that point will actually not be visible when we are looking at it in isometric view. So, now let us take the examples and let us first ascertain where the center of the sphere is going to come, and then we draw the sphere. So, let us assume that this block in the bottom, this one, is actually a square base prism, and on top of that in the center the sphere has been kept. So, the dimension remains the same. So, let us start drawing this. I will first draw the square base prism, basically a cuboid. I am directly drawing it, however, certain portions of it will be actually hidden. So, I will start drawing in lighter color here, we will darken it later. Okay. Now, the sphere is resting on the top of this square, right in the center of this. So, this is the point P, which we can see here. So, this is the point P here. Now, the sphere has certain radius, which is, now here if you see, we are taking the exact radius. So, this was say okay, so they have taken it as 5 units, I have assumed it to be 4 units. So, if this was 4 units, we have taken it exactly the same size, and if this was also say 4 units, so what we have is that we have the center coming somewhere here, because we are measuring in iso only. So, 1, 2 units up, this is the center C. Now, if we have to take the one way could be that we actually, which is actually the correct way, we can actually draw at this height, we have to first draw a circle. We can do that, or what I am doing right now is just ascertain that what this radius is going to be. So, all I am doing is, I am not really going to take this into account, but I am just calculating. You can measure or you could just arrive at this. So, this is the radius that I am going to take, and I will be drawing the circle, which will be approximately this. Okay. So, now I will change the color, because this is the final one. So, we ascertained where the center of the sphere is, we ascertained the radius, and that is what we are going to draw as a circle. This is the final projection of the sphere that we are going to see, which is kept on this cuboid, and anything behind that is not going to be visible. So, we can actually draw it in dotted lines. This is how our combination of solids is going to look like. So, this is the sphere here, and this is the cuboid in the bottom. All we have to do is we have to ascertain the point of contact and the center of sphere, and then we will be able to draw it. Let us take few more examples and things will become clearer to you. Okay. So, this is again a cuboid on top of which a hemisphere has been kept, but the hemisphere is bigger. Okay. So, okay, some dimensions seem to be missing here, say if the radius is 25 here. So, 40, 44 in the bottom, and so we will first draw the cuboid in the bottom. Very simply we can draw this cuboid. Okay. Now, this hemisphere is resting on top of it, and it has a circular base, the center of which is lying here. So, we already have identified the center, which is O, and it has 25, 50, approximately half of this. So, what we are going to do is we are going to identify this circular base. Okay. This is where the circular plane, the circular face of the hemisphere is going to come. So, what we actually have is we have this circular base. Now, we may not be able to see it fully, but in hidden it will be there, because it is actually not hypothetical here. In a sphere it is a hypothetical one, but in this particular case where it is a hemisphere, it is the real one. And then the height of it, the radius of it is this, okay, which will come somewhere here. So, when we join this, we will actually be seeing the hemisphere like this projecting and the cuboid beneath. So, if I have to now darken it, we will actually see this dotted line at the back of it, which is half of the circle in the base, and then we see the hemispherical part and the remaining part of the base circle. Okay. This is all dotted, we will not be seeing it, it is beneath the circle. And then we see the solid lines. So, anything that is visible in the front is seen as solid. So, those fundamentals remain same in both ortho and iso, and another dotted part. So, this is what we will be seeing if we have to convert this orthographic into an isometric. Very simply, you have to identify the center, we have to identify the radius, which is going to be, you could calculate it. So, 25 into 1.2, we could do it that way also, or we could draw and we can ascertain where this radius will be, how much this radius will be. Let us take few more examples and then see. Now, there is a frustum of a cone, on top of which a hemisphere has been kept, but this time it is not inverted, it has its circular base upwards. Okay. Very simply, now I am taking the combinations of solids, because otherwise if we were to take only spheres and hemispheres, then we can't really have it will not be very difficult, but if we have to ascertain where exactly the circle, the hemisphere is going to be kept on another solid in reference to another solid, that is what we need to understand. How do we do that and how do we make the sphere or hemisphere out of it. So, this is the frustum of this cone. So, what we have is we have a 50 diameter in the base. So, for example, this is, I am assuming this to be, each unit to be 10. Okay. So, this is the bottom circle. So, this is how you get the bottom circle for the frustum. Now, this is the center point, this is the axis, this is where the axis is passing through, if you see this, right. So, this is the axis. Now, if we take this, right above it 5 units, so 1, 2, 3, 4, 5, say here, we have another one, it is 3 units, so 1, 1.5 this side and 1.5 that side. So, we will have another circle, which will be the circle of the frustum. Okay, so rather I would bring it down, because so I am assuming a different height. So, let us assume that this is here itself. Okay, and we draw the circle again. This is the top circle, this one I am talking about. We still have not come to the hemisphere. So, this is the top circle, and if we join this, we will get the frustum. Okay. Now, we have to draw the hemisphere. Now, hemisphere has a diameter 50. Okay. So, which means that this height is 25, half of it. This is the point where the hemisphere is resting, we already know the bottom point. And if we look at it in the height, so 25, this is 20 and half of it 5. This is where the top circle is going to come, and 25. So, we will then draw the top one. So, 25, I am just drawing the top circle of the hemisphere. Okay. This is at the top. Now, this is where, this is how we are going to see our circle. This is the plane, the circular part of the hemisphere. Okay. And this is where it touches the bottom, but we know this is the center, this is the radius, we already derived that. So, taking this center, this as the center and this as the radius, we will draw the remaining part of the hemisphere. So, this is the hemisphere resting on this frustum. Now, I will darken it, you will be able to make better sense out of this. So, I am drawing from top to bottom, whatever we are seeing on the top. This is the circular surface of the hemisphere. This is the hemispherical part. Okay. Now, we will see the top of the frustum, and the back is actually going to be hidden. This is the incline of this circular frustum and the bottom one. Now, if you look at this, this is a frustum on top of which a hemisphere has been kept. Very conveniently, all we have to do whenever we are drawing the sphere or hemisphere is to locate the center and the bottom point where it is touching. Even if, so usually the center will come with reference to this. So, first we will locate this point P and then C, and then we will derive the radius wherever, whatever it is, and then draw the rest of it. Be clear in your mind, do not confuse. If we are drawing this in actual units, we take this in actual units and enlarge the radius which is to be taken for drawing sphere or hemisphere. If we are using the ISO units, in that case this radius will be the actual dimension. So, you just have to decide what scale you are choosing. If you are choosing isometric, drawing sphere becomes easy, but the rest of the drawings every time you have to change into isometric scale. We can do it otherwise, we can use the actual dimensions and just scale up this particular dimension, which is the radius, by 1.2 times. Okay. Couple of more examples. Now, this one is again a frustum on top of which we have a part of the cylinder, on top of which we have a sphere kept, but it is cut and it is not hemisphere. So, it is cut at a very different height. Okay. This is what we are going to be seeing here. Okay. So, let us draw the frustum again. Okay. So, I am assuming each one to be 25 units, this one here. So, 75 the bottom one. So, this is what you get as the circle. Okay. Now, taking the center, so this is 25, another 1 unit, the small frustum. Okay, maybe I will take 2 units for convenience here right now, and instead of 63, let us assume that this is 50. It makes it easier for us. So, 2 units. So, I have changed the unit, do not confuse, I am just doing it because it is easier for me to draw here. When you are drawing, you can actually take the actual dimensions and go ahead with it. So, this is the top of the frustum, we can join them later, you do not need to do it right away. Okay. Now, on top of this we have another one which I am assuming here to be say 25. Okay. So, if it is 25 and this is say half of it 12.5. So, what we will have is this is just 1 unit like this. Okay. So, this is what your small circle would be, which is for the cylinder, and then say half a unit above it we will have another circle which is just 1 unit. So, what we have is this cylinder coming here, okay, which is the cylinder, which is the neck. Now, what we have is we have arrived at this point, okay, and say this was radius 25. If this was radius 25 and this is now one dimension which is missing here is this distance. So, either we have this distance or we have the total distance, whatever. So, what we will now do is we already have arrived at this point, we will arrive at this center. Okay. So, so what we have is from this top point which was the intersection of this top circle, whatever this distance is we will take that distance here. Now, this is the center, say O. So, we have arrived at the center O for this sphere. Now, this is 25, we are drawing the actual dimension. So, 25 and this is the circle, this actually merges with the circle here. So, we know that this is the circle which is also the plane where the section is the sphere has been cut, and taking this one here we could actually draw if it was 25 radius. So, what we actually have is a square at the center which will help us arrive at the radius, or I could have measured also, but I am just deriving it, it is better to do it that way. This is the radius. Okay. Taking this as center, this as radius, we will now draw a, but this will not be complete. Okay. This will not be complete. At this point we will have an abrupt cut which is going to be this. Okay. So, now if I darken this one, you will see that we have and then at the bottom we will have this coming like this. Then we have another circle which is for the frustum, dotted part, slant of the frustum and the dotted part of the frustum at the back. This is what we will see when we are drawing a combination of these three which have circles as their surfaces, the curved surfaces. So, this is how we are going to derive if the sphere is being cut at a point other than its center. Okay. So, this is how we can arrive at a sphere which is being cut through some other point at any other distance. In a similar manner, you could actually draw any drawing. All you have to remember doing is identify where this. Now, we could have drawn the other way around. So, if we are starting from the top, you could do the same thing. You can first draw this circle, locate the center and draw the rest of the sphere. We can start with that. So, if we have this which has a radius of, okay, so it has a radius of 25. So, this has a radius of 25 and assuming this has a radius of say 20. So, let us assume this to be having a radius of 20 which is the top. Now, I am going to draw it bottom down. Okay. So, this is what you are going to see on the top of this hemisphere. Sorry, this is not a hemisphere, this is part of a sphere, section of a sphere. So, this is what we have drawn here. Okay. Now, we have to locate the C. So, this was say 20 and this was approximately above 10. So, below this we will have the center of this sphere, okay, which is C. So, we located this C here and this was 20, we can take it slightly bigger than that. So, when you draw the exact dimensions, you will get to see what comes. And now I have this C, I have this. So, this we are only drawing for a reference, okay. Taking this as center, this as the radius, what we are going to do is we have to draw the rest of the sphere, but it will come up, okay. So, it will come up like this and then it merges in this circle which is at the top, because this is not a hemisphere, it is actually getting chopped off at a height other than its center. So, this is what you will see when you draw this. This was the point P which is here, and then you can continue to draw it down. So, we can have another circle, radius 50, sorry, dia 50. So, you can continue to draw other circles and then join them at a height, at certain height, whatever the height is given, say approximately here. We have another one, right, this is here. So, what we have is this frustum which we can see here. We also have a square at the bottom which is what we can see here. So, we have this and then we have a square of 80. So, we can draw a square of 80 and then we can join this. So, this will be part of the pyramid, a square base pyramid, as you can see. So, if I have to darken this, you can see on the top we will see a circle, the rest of the sphere, okay. The remaining part of the frustum, whatever is seen, when you draw it accurately you will know what is going to be visible and what is not. The square, and the square pyramidal base. This is how we can draw it from top to down, or we could draw it from bottom up. Either ways the process does not change. We will draw it exactly in the same manner. For sphere, which is what we are going to focus on today, we have to identify where the circle is and where the point of contact is. It will help us arrive at the radius which is going to be taken, and then we will derive the sphere, the entire sphere. It might be cut from wherever, anywhere, but we will be deriving it in this manner only. So, I will stop my lecture here today, and by the end of this week, this lecture, we have covered all types of solids and two-dimensional objects. From the next week onwards, we will be looking at how to draw isometric projection of combination of solids like we have done for the orthographic. So, we will first have to draw the orthographic projection of the combination of solid, intersection of solid, and then derive the isometric projection from it. Also, we will be looking at the orthographic projections of, say, various combinations or chiseled solids, or whichever way they could actually be parts of buildings, and then see how we can convert them into isometric drawing. So, many a times we will be given with the orthographic projections and we will be required to draw isometric drawing out of that. This is what we are going to see in the upcoming week. So, thank you very much for being with me here today in this lecture. See you again next week. Bye-bye.